In this video, we're going to be solving this question on functions and domains in Algebra 1. The problem statement says, let function of x, or in this case is f, we're defining it as f, equals 3x plus 3 over x plus 1. Find the domain of f. Now before we begin, let's figure out how to define the term domain, because we're going to need to know what it is before we begin to solve the problem. So when it comes to dealing with functions and algebraic functions, the domain of a function is the set of all possible values it can input that produces a valid output. So, for example, if you have a fractional function definition like this, of course you couldn't have the denominator equal to 0, because then you'd be undefined. The fraction itself would be undefined. So the denominator could not be 0, so that would not be a valid output. So the domain in this case is, in all cases actually, is all the values the function can input and produce an output. Because if you have a 0 denominator, then it means you're not going to get an output, it's just going to be undefined. So that would not be a valid input, and thus it would not be included in the domain. Okay, so domains all the values a function can input and produce a valid output. That's an important information to know. There's also the range of function, but we're going to get into that in the next future videos. The range is basically the set of all values a function can output ever, no matter what the input is. Okay, so now we know what the domain is. We can now begin to solve the question. So what we need to do here is find out which values of x make the function undefined, so we can work from there. So this is a fraction right here. We know that this x plus 1 part in here must not be equal to 0. That's something we know right away. X plus 1 not equal to 0, because that would make the fraction undefined. We also can't have 3x plus 3 equal to 0, because that would mean the numerator would be 0, and that doesn't work as either in a fraction. And it just so happens, if you look at this, if you have x equal to -1, then that makes both the numerator and the denominator 0, because -1 plus 1 is 0. You could find this by just first looking at this first case here. How would you get x plus 1 equal to 0? Simple, x equals -1. You would then look at the numerator and notice, if you plug my -1 into x here, 3 times -1, that's -3 plus 3, that's going to be 0. That would mean both the numerator and the denominator would be equal to 0, which would definitely make this fraction undefined. So x equals -1 is our primary prohibited value here. It cannot be that. And the reason why we know all other values work is because if x is anything else, then both the numerator and the denominator will be a non-zero integer. If it's 0, for example, 0 plus 1, that's 1. If it's 0 up on the top, 3 times 0 is 0, plus 3, that's 3. And in fact, for all values of x, you'll notice that the function will always output the integer 3. If you had x equals 2, for example, 2 plus 1, that's 3 on the bottom. Then 3 times 2 is 6, plus 9, that's 9, then over 3, that's 3 again. So we've found our, basically unsuitable values here, and that's just one value, x equals -1, so we have to exclude that from the domain. Now typically, when we're being asked for the domain of a function, we need to provide the answer in interval notation. And interval notation uses parentheses and brackets to describe an answer or inequality between two things or numbers. So in this case, we know that x cannot be -1, but that it can be every single other real number. So we can write the following interval. We have parentheses here. We're always going to use parentheses, not the square brackets, when it comes to infinity. So we have -infinity here. That's because beyond -1 and going down, -2, 3, 4, it could be anything into the negative infinity range. Then we have -1, also parentheses, because it cannot be -1. Then we want to join this interval together using the union symbol. because we have to include the positive values of x as well. We're going to join this to parentheses -1, because it can't be -1, and positive infinity, because x could be anything all the way up to 5 billion. It would still output a result when put into this function. So we've got our completed interval notation here. This is the answer to this problem. That's the domain of this function. We've got the interval -infinity and -1, where we're all using parentheses here, then joined to -1 and positive infinity, because x cannot be -1 in any situation. And x could be in either of these two intervals. That's why we're using the union here. It's kind of stands as an and/or in this case. So that's how you would solve this problem on algebraic functions and finding the domain. Again, the domain is all the values a function can input and produce a valid output, and not something undefined, like a zero denominator. And we've successfully solved this question in Algebra 1 relating to algebraic functions.